Okay, now I'm showing you all the types of t-tests, all the types. Okay. One of each type I'll show you. Now this is one when they give you a list of values. I'm reading this amount.
So that isn't by each also the brightness?
Brightness of this is the brightest. This brightest won't affect that.
But I'm saying the light or something. The light off. So the
light off. Benga recorded the times taken to complete his homework over a whole academic year. He found that they follow a normal distribution with mean as 34. The following year, he changes classes and thinks that his new teacher sets more homework. A sample of times taken to complete the homework recorded at nearest minute is given. Correct? 34, 27, 42, 45, 38, 26, 30 and 42. Test whether there is sufficient evidence at 10% significance level that a new teacher sets more homework. Now what is important here is you need to understand, you have to write your null hypothesis first. What is your null hypothesis?
That the teacher sets.
That the mean is 34. There's no change.
There's no change.
There's no change. So your null hypothesis is, I'll put this up,
You say that the teacher keeps the same amount of homework?
Yeah, you can write that, but they won't give you full marks.
Why?
Because you have to write it mathematically.
Okay.
So null hypothesis, whatever the old teacher said, the new teacher said the same thing.
Yeah.
No change. Remember, null hypothesis, no change. Alternative hypothesis, what you have to look at? You have to read the sum carefully and it's given sets more homework. Yeah. Means your that mean is greater than 34. So you're hypothesizing that mean is greater than 34. How do you check that? You take the timings.
So you go to the list and then
yeah, you go to the list in the calculator, put all timings in the list. All the values in this.
Yeah.
Then you go to test, go to t-test, and you have to do one sample t-test.
I did that, yeah.
Now you have to take the list, not
list,
variable.
Yeah, list one.
List. Now mu is not equal to mu naught. Now my mu is greater than mu naught.
Yeah.
So I have to take this greater than sign. Correct? And then what is the mu naught value?
34. So
you put that 34.
Okay.
And list one.
Yeah, I know.
So now your t value, so you have to write t test to apply. Yeah. Assumption that the data follows normal distribution, that's the assumption. Yeah. If they ask you, now here they're giving you, but sometimes they'll ask you, okay, data follows normal distribution. So t is equal to 0.579 and p value is 0.290. You compare p with SL.
Insufficient.
So insufficient evidence to reject H0. So this is the first type of sum. Okay? Yeah, so your H0 is, your mean is 14.3 and this things are higher than 14.3.
That's the, what's it called?
Alternative hypothesis. Higher means you put a greater than.
Like piece of data.
So this is your n, number of data points. The mean sample is 17.3 and the estimate of population standard deviation is 8.6. So you write your null hypothesis, alternative hypothesis.
So you will what's it called?
T-test only.
So one this thing.
T-test.
One sample.
One sample, yeah. This is one sample only. We are working with one sample.
And then?
Now we are working with variable.
Okay.
So variable, what will you do? First you'll put in the values.
14.3.
So mean is 14 is greater than 14.3. So first greater than sign was already there. Yeah. So I'll just change that. Now this is your sample mean. X bar is your sample mean.
So 17.3.
17.3. Your 17.3 is the sample mean.
And SX is
SX is your estimate of population standard deviation.
8.6.
8.6.
And N is how much?
N is the sample size. 30 pieces of information you've taken. And then you enter.
Like P is 0.033.
0.0330.
So that's sufficient evidence to reject H0.
So sufficient evidence to reject H0 since your P is less than SL. Yeah. So when your P is less than SL, there is a sufficient evidence to reject it. Means you reject H0. Yeah. Means you're accepting that the mean is indeed greater than 14.3.
You write the t values are?
You have to write the t value.
Why?
You have to write because you're using the t test. So far we did two types. Now the third type is when you have two samples. When you're working with two samples, there are two assumptions we have to make. We have to assume that it's a pooled sample t-test. It means that both the samples are having the same variance. We have to assume that both the samples are having the same variance. Okay? And both the populations are normally distributed. So the example for this would be this. So Divya measures masses in kilogram of random sample of dogs from two different breeds with the following results. Breed A, the data is given. Breed B, the second set of data is given. The number of dogs in the samples may not be the same.
Yeah.
That's important.
The standard deviation is the same.
Standard deviation is same. That's an assumption.
Variance.
Yeah, variance is same. Standard deviation depend on each other. Is the evidence at 5% significant level that the two breeds have different mean masses? So what's your null hypothesis? No change. So mean of A is same as mean of B.
Yeah.
What is the alternative hypothesis?
But they are different.
They are different. Mean is not equal. Now what will you do in this case?
You do this in two samples now?
Yeah, two samples you'll be doing. But before doing two samples, what do?
You put it in two lists.
You put the values in two lists. So you put in the values in two lists. I'm not doing that. You put the values in two lists. List 1, list 2. In two lists. Then what do? Menu.
Pull on.
Pulled on. You go to test. T-test. You take two samples. You take list because we have put in this. So mu.
So now you know.
Mu1 is not equal to mu2.
Not
equal to mu2. You've entered. I haven't entered. So list 1, list 2. There already. Correct. And pulled on.
Yeah, I do that.
Pulled on and you get the values.
So that's not enough values.
Huh?
That's not enough values.
So no, you don't write that. You write a T and you write your P.
Yeah, that's insufficient evidence of jaggation.
But you have to write all this in the paper.
Yeah.
Okay. The next type is two sample t-test with the variables given. So you can try this out on your own the same way. Come on. So state the two assumptions to make the t-test. That both follow normal distribution. Yeah. And second assumption, pulled on. They are the same variance.
Okay.
They are drawn from the same population which has the same variance. These are the sample variances, please. This is the estimate of population variance.
Oh,
so these are derived from the sample. This may not be the same.
It's not true.
But, it's not true, but
you
assume it to get the answer. Yeah. State appropriate hypothesis. What's your hypothesis that you'll state?
The first. The null hypothesis will be the first group completes the task at the same time as the other group does.
No.
Why?
What will you write? You can't write the entire sentence. You can write a sentence, but it's preferable to write the equation.
The mean
mu1 is equal to mu2. That's it.
Yeah, the mean is equal to mean.
So you write that. Right? mu1 is equal to mu2. Write like this only. You don't have to
I'm saying like it.
Okay. What's your second alternative hypothesis?
That they're not equal to each other. Not equal to each other.
No, read the question.
Oh, what is the first group? Oh, yeah. So the first group will be less than the second.
Yes. Determine whether first significantly faster means this is a time.
Yeah,
so faster means the time will be less.
Yeah.
Now you work it out. Now what will you do? You put this value where?
In this one.
No, not in the list. Now your variable will come in. Test. This is a fourth type. Two sample variable. And here you will put your mu is less than this. You put in your first mean, first sample size, sample mean is 18.3. You enter the data basically. Your estimate of standard deviation is 12.3.
Root, no?
Population variance, yes, you're right, root. So square root of 12.3. You directly put in the square root. Sample size 23. 20.6 is the second sample mean. The variance is given, so the population standard deviation at root 15. Correct? Sample size is 28. Pulled on, you leave it, and that's your answer. So you write the t value minus 2.20.
One second.
What happened?
Yeah.
Correct? Minus 2.2 and 0.0162. Correct?
Yeah.
So conduct a test and state your conclusion at 5%.
So there is sufficient evidence to reject the non
So listen, sufficient evidence to reject H naught at 5%.
and insufficient
At 1%,
insufficient evidence to reject.
reject H naught. So these are the
how many types are there?
4 types. These are the 4 types. And
that's it.
so chi-square you had 2 types, and t-test there are 4 types. One sample with list, one sample with variable, 2 sample with list, and 2 sample with variables.